Like so many good stories, it starts with an individual. And Jonathan Ledgard approached me and said, I know you, because I'd met him many years earlier. And we talked about Africa, and we talked about emerging economies, nations, infrastructure. So we'd had those conversations by way of background. So he said, you're a pilot, you know about sailplanes, you know about helicopters, you've flown fixed wing, and also you've designed airports.
There is no thinker in the world, I think, who understands the relationship between sky and ground and sky as profoundly as Norman does. I mean, invented the modern airports, built the first spaceport, and now having built the largest airport in the world, mischievously I said, Norman, look, you've built the biggest airport in the world, just come and build the smallest.
And so that was really the start of a conversation. And Jonathan explained this kind of convergence of the most dynamic, futuristic technology of the drone associated with the military, but here in a humanitarian concept, that it could deliver blood, it could deliver cargo, particularly in Africa. And so he described how it could leapfrog infrastructure, countries which don't have a network of road and rail.
I'm an Africanist and I'm interested in emerging economies. And we look at what is going to happen in those economies in the next 10 years. They don't have an industrial base. So these towns, which now have 20, 40, 50,000 people, will end up with 200,000, 1 million people, with 70% youth unemployment. By 2025, 2030, most of those towns will have a drone port, which are connected in a network system to other towns.
So got tremendously excited about this, shared it with colleagues, Narinda, structural engineer, Roger, and out of that came the idea of a modular building system that would be capable of being constructed by communities.
One of our first questions to Jonathan and talking about drone ports was, do you actually need a building? Don't you just need a truck or a series of shipping containers with the equipment inside? And we quickly realized that drones, particularly in Africa, need a hub, need a place where they can be built, the technology could be advanced, and as that technology advances around the drone itself, the building can advance and evolve at the same time. So imagine the beautiful green, lush landscape of Africa with a brick that has naturally come from the ground and has a buoyancy because of the structural form, a buoyancy that's lifted it through above the greenery. So you're left with something very beautiful and symbolic on the landscape.
The idea for the drone port arose through discussions with Norman, with Jonathan, with Narinda, and it was to take a form that we know and has existed for a long time, the shell, and make it specific to the brief of the drone port. So our response is a modular response. It can be built and extended. It can be made in different areas. What we can bring is the knowledge of the geometry that is required and the ability to deal with particular effects such as seismic forces, earthquake forces.
The big question then, an early design concept, is how do you translate that into reality? So my foundation was able to harness the energy, the enthusiasm, the idealism of university students and their professors. So we're looking at MIT in America, the Polytechnic University in Madrid, ETH in Zurich, EPFL in Lausanne.
The drone ports will be constructed with local materials using local labor. The goal is to maximize the use of local resources in the community. The low-tech structure is made of earthen bricks, thin tiles of compressed soil, built using an 800-year-old technique which can be constructed with minimal support during construction and has no steel.
The vault was created using RhinoVault, which is a program developed by Philippe Bloch and his Bloch Research Group, who's one of the founding partners of ODB Engineering, which is the firm that is collaborating with Foster on this product. So the geometry is somewhat form-found, using structural parameters to create an optimized geometry.
Bringing these together and then bringing in industry with another foundation, the Lafarge-Holcim Foundation.
So in the case of Lafarge-Holcim, it meant redeveloping a product that already existed. Durabrick is a building brick that exists for building predominantly affordable housing in emerging countries. And it was a matter of reshaping it, making a tile, actually more than a brick, that has at least as good properties as the brick itself, so that it really works.
And out of this is just a great story, because the foundation was able to bring all these different parties together and to use the Venice Biennale as a showcase, as a demonstration of a group building a typical module, and its creation being filmed becomes the manual for those more remote rural communities. So when you see this vault emerging in the Arsenale in Venice, you realize that its coloration is the same as the historic buildings around it. So if it's capable of being built under the leadership of a master mason, but essentially by students, then you realize that it can be recreated across emerging economies. And being a self-build, the minimum products are transported and the maximum engagement of the local community. So it starts with the idea of a drone port, but the drone port goes beyond it. It's like a catalyst for other industries, education, marketplace, community centers. So it's a very, very wide application.